This segment explores the essential functions and configurations involved in creating and managing an Azure Container Registry, ACR, as part of the overall AZ-104 Microsoft Azure Administrator course. It builds upon the foundation established in previous modules that introduce techniques for provisioning resources with Azure Resource Manager, ARM, templates, or bicep files, and for deploying various Azure Compute resources. Containers have become increasingly popular in modern application development due to their portability and efficiency. By leveraging Azure Container Registry, organizations can securely host Docker images and other artifacts while maintaining oversight through Azure's unified portal. This approach helps ensure consistent deployments across various platforms, including Azure Kubernetes Service and Azure Web Apps, emphasizing robust security, scalable storage, and streamlined automation. This session will address critical operational considerations when working with containerized solutions. It also provides insights into how ACR seamlessly integrates with existing Azure services and enterprise-grade development workflows. A container registry is a repository that stores and distributes container images, frequently used in Docker-based workflows. These registries facilitate efficient sharing of application artifacts by providing a centralized catalog of images that can be securely accessed by development teams and automated pipelines. Container images are immutable packages containing everything required to run an application, including binaries, libraries, and configuration files. This streamlined approach to packaging ensures consistency in development, testing, and production environments. Publicly available registries, such as Docker Hub, offer convenience for open-source projects and demos, but enterprise environments often prefer private registries to avoid potential security or compliance risks. By establishing a private registry, organizations can manage authentication, control access, and closely monitor usage. Registries also enable version control through image tags, supporting the identification of specific builds or releases. Through this mechanism, container registries underpin modern DevOps practices, improving portability, scalability, and deployment velocity. Azure Container Registry, ACR, provides a dedicated platform for storing and managing container images within Microsoft Azure. It supports Docker-compatible interfaces, allowing developers to push and pull images using familiar commands. ACR offers 3 key service tiers: Basic, Standard, and Premium, each designed to accommodate different workload sizes, throughput requirements, and advanced features. Basic focuses on entry-level usage with minimal throughput, while Standard caters to moderate production workloads and scales effectively for larger teams. Premium delivers the most feature-rich experience, including higher throughput, geo-replication, and image content trust capabilities for enhanced security and global distribution scenarios. The registry can store Helm charts and other container-related artifacts, enabling various deployment strategies within Azure, from Kubernetes clusters to app service-based solutions. Because it leverages Azure Active Directory-based authentication and role-based access control, ACR facilitates secure, integrated workflows with minimal administrative overhead, making it a vital component in enterprise DevOps pipelines. To create an Azure Container Registry, administrators can use multiple tools such as the Azure Portal, the Azure CLI, or resource templates in ARM or bicep. When employing the portal, users select the desired subscription, resource group, and registry name. Then choose a location and service tier. This graphical approach is straightforward for individuals who prefer interactive configurations, as it visually summarizes the chosen settings and provides helpful guidance along the way. Alternatively, the Azure CLI method offers a scriptable solution ideal for repeatable workflows. Commands like AZ-ACR create let administrators define registry parameters, making it possible to automate large-scale deployments or integrate creation steps into existing DevOps routines. Resource Manager and Bicep templates deliver infrastructure as code benefits by describing registry configurations in declarative syntax. This consistent approach reduces manual errors, supports version control, and simplifies updates or migrations to new resource groups or subscriptions. Azure Container Registry relies on Azure Active Directory to authenticate users and service principals. This approach maximizes security by centralizing identity management and offering fine-grained access control via Azure Role-Based Access Control, RBAC. Administrators can assign roles like owner, contributor, or reader at the registry or resource group level to regulate who can perform actions such as pushing images, deleting tags, or modifying resource settings. Service principals, commonly used service identities in automated pipelines, require OAuth tokens or managed identities to access ACR. For container hosts, such as virtual machines or Kubernetes clusters, administrators might enable managed identity authentication, reducing exposure of credentials. ACR also supports individual repository scope permissions for scenarios where distinct teams need restricted access to specific images. This combination of identity-driven access and RBAC fosters consistent, compliant security practices, helping organizations meet governance requirements without sacrificing operational efficiency or developer flexibility. Azure Resource Manager, ARM, templates, and bicep configurations streamline the creation and management of container registries by offering reproducible and auditable automation. Building on skills developed in earlier units, operators can extend their template definitions to include a Microsoft container registry/registries resource. Parameters such as registry name, tier, location, and network rules can be declared in a resource file for predictable rollouts. Developers may define outputs for referencing the registry's endpoint or resource ID in subsequent deployments. This approach ensures that any environment, test, staging, or production reflects identical infrastructure definitions, minimizing divergence and promoting reliability. Bicep language further reduces complexity through concise, modular syntax that references predefined variables and modules. Templates can integrate with continuous integration pipelines, facilitating the entire application lifecycle from build to deployment. Moreover, they support version control for quick tracking of changes. Each modification becomes traceable, ensuring that any rollback operations or iterative improvements can be managed with confidence. Once a registry is provisioned, developers can push container images to Azure Container Registry using Docker or the Azure CLI. Docker-based workflows often rely on Docker push commands following a local build, with the registry's login server specified as part of the image name. For example, my registry Azure CR io/image:/tag . Before pushing, users must authenticate by running AZ-ACR login or enabling Docker's built-in credential helpers. Custom tags, such as version 1.0 or latest, provide clarity about environment compatibility or release status, aiding continuous integration or automated pipelines. Alternatively, AZ-ACR build allows direct image builds from local or remote source code repositories, eliminating the need to manage Docker locally. Authentication tokens can be configured to allow ephemeral or permanent access for build agents. Incremental building and pushing of images keep pipelines agile, while image scanning and retention policies ensure that only approved and current artifacts persist in the registry. Pulling images from Azure Container Registry involves specifying the fully qualified image name, including the registry login server prefix. Container runtimes like Docker or Kubernetes query the registry to retrieve the requested artifact. Before pulling, the environment typically requires appropriate authentication, which could be handled automatically when using Azure services configured with an assigned managed identity. For local testing or non-Azure hosts, Docker pull myregistry.azure CR io/image:/tag is run after signing in through Azure CLI or Docker logins. Efficient layering ensures that only new or changed image layers are downloaded, reducing bandwidth usage. For production workloads, consistent image tags and versioning practices confer stability and traceability, helping operators quickly identify which build is running. Pull requests to ACR are subject to security policies and RBAC rules. In scenarios where multiple container hosts rely on the same images, geo-replication in a premium ACR instance provides low-latency access across different regions. Azure Kubernetes Service, AKS, often leverages Azure Container Registry for hosting images that power containerized workloads. The integration process typically involves granting AKS permission to pull images through Azure Active Directory, eliminating the need for embedded credentials in manifest files. Administrators can configure the AKS cluster identity with the AKR role, ensuring the cluster automatically authenticates to ACR. Once authentication is set, Kubernetes deployment manifests or Helm charts can point to the registry by referencing myregistry.azure.io/image tag in container specifications. This workflow promotes a seamless chain of custody, where containers are built, pushed to ACR, and then consumed by AKS with minimal manual intervention. Leveraging automatic scaling within AKS, organizations can respond to fluctuating demands by spawning new pods that immediately fetch container images from ACR. This approach enables robust, production-ready orchestration solutions aligned with DevOps practices. Properly managing tags and retention policies ensures cluster stability and resource optimization. Azure Web App for Containers can directly deploy images from Azure Container Registry, providing a lightweight alternative to running containers in full-scale orchestrators. Administrators configure the web app's container settings by specifying the registry URL, repository name, and tag, then supplying credentials if no managed identity is in use. The platform pulls the designated image upon startup, streamlining the path from local development to a production environment. This architecture simplifies certain application scenarios, such as microservices that do not require a complete Kubernetes environment. Developers can leverage environment variables, networking configurations, and scaling options within the web app to customize performance and connectivity. As images evolve, updates can be triggered automatically or manually when new tags are pushed. The service also monitors container health and restarts instances if a failure is detected. This flexibility helps teams achieve rapid iteration while maintaining robust governance through role-based access and policy enforcement. Azure Container Registry integrates seamlessly with continuous integration and continuous delivery (CI/CD) pipelines, whether powered by Azure DevOps, GitHub Actions, or other third-party platforms. Under this model, each code commit can trigger an automated build of container images, followed by a push to the registry. Pipelines often include quality checks such as unit tests, vulnerability scans, and code validations before publishing. Once images are in ACR, the pipeline can proceed with staged deployments to services like AKS, Azure Web Apps, or other environments specified in the deployment process. This consistent automation reduces manual steps, accelerates feedback loops, and ensures that only verified artifacts reach production. Credential management is often simplified by using service connections or personal access tokens that interact with ACR securely. Workflows might include versioning strategies that tag images based on build IDs or commit SHAs, further enhancing traceability. This tight integration fosters agility, reliability, and governance in container-based development. Effective management of container images in Azure Container Registry involves strategic tagging, retention policies, and routine housekeeping. Teams typically use semantic versioning or date-based tag formats, ensuring that stakeholders can identify and track builds. Administrators also configure retention policies that automatically delete old or unused images, preventing the registry from becoming cluttered with stale artifacts. This housekeeping not only optimizes storage costs, but also eliminates potential confusion over which image version to use. For advanced scenarios, image scanning tools assess vulnerabilities or compliance issues, feeding reports back to security teams for prompt remediation. ACR supports image content trust by enabling code signing of images, allowing operators to verify authenticity before pulling. In addition, logs from push and pull operations provide insights into usage patterns so managers can evaluate efficiency and enforce stricter policies if necessary. By systematically applying these practices, organizations maintain a container library aligned with performance goals and security mandates. Azure Container Registry tasks, ACR tasks, enable automated build, test, and deployment workflows directly within the registry. By defining a task, developers can instruct ACR to periodically check a Git repository for source code changes, build a new container image, and push it to a specified tag whenever updates occur. This continuous integration approach offloads build processes to the cloud without relying on local Docker installations. Task definitions may include build arguments, environment variables, and triggers, such as commits to a particular branch. Some organizations configure multi-step tasks to run unit or integration tests before finalizing the image. On completion, automated notifications or webhooks can inform other systems. Other advanced features include base image updates, where dependent images automatically rebuild if a base image changes, protecting deployments from vulnerabilities. By employing ACR tasks, teams gain a flexible, scalable mechanism for container pipeline automation, boosting productivity and reducing operational overhead. Robust monitoring and logging strategies help administrators gain visibility into Azure Container Registry activity and diagnose issues. Azure Monitor and Log Analytics can aggregate push and pull logs, enabling the creation of custom dashboards or alerts that trigger when thresholds are met or anomalies appear. For example, an alert could be set to notify engineering teams if pull requests spike unexpectedly, signaling potential misuse or a sudden surge in demand. Network rules and firewall settings can be monitored to ensure that registry access remains compliant with organizational policies. Diagnostic logs may reveal attempts to push unapproved images or unauthorized access attempts, aiding in incident response. Additionally, combining usage analytics with cost management aids in fine-tuning the appropriate ACR service tier. Over time, capacity planning becomes more precise, ensuring that budgets and resource allocations align with actual consumption patterns. This systematic approach to observability helps maintain a reliable and efficient container registry.